Welcome to the Explainer. Okay, let's dive right in. We're going to talk about a really fascinating story from the world of AI. It's one where the next giant leap forward, well, it might not come from thinking bigger, but actually from thinking a whole lot smaller. You know, when we think about AI progress, our minds usually jump to headlines that look just like this, right? It's like a heavyweight boxing match between these massive companies. Every new version, GPT, Gemini, Claude, you name it, is expected to be bigger, more powerful, just more. And that really seems like the main event, doesn't it? The undisputed championship. But what if I told you the most important breakthrough happening right now has nothing to do with building a bigger model? What if it's all about making a smaller one smarter? So that question right there, it leads us to this really fascinating piece of academic research that just completely flips the script. It's like we've all been so focused on the size of the engine that we've totally overlooked how we're driving the car. And what this paper reveals is how a much smaller model can, believe it or not, absolutely outperform a Titan. Okay, so here's the big idea. Researchers found a way to dramatically boost a model's performance. But, and this is the key, they didn't do it by adding billions more parameters. Instead, they changed how the model uses its computing power during inference. That's just the fancy term for when it's actually solving a problem. I love this analogy. It's like the difference between cramming more and more books into a library versus just giving a genius librarian a little more time to find the perfect answer. And this technique has a name. It's called test time scaling, or TTS for short. So instead of just spitting out one quick answer, TTS lets the model explore a bunch of different paths, kind of weigh its options, and then commit to the best possible solution. It's a huge shift from a single gut reaction to, deliberate, structured thinking. Okay, so how does this more time to think thing actually work? What does that even mean in practice? Well, the secret weapon here isn't just about more time. It's about a super clever verification system that acts almost like a coach, guiding the model's every move. This whole process relies on something called a process reward model, or PRM. Now, the best way to think about a PRM is not as the star player on the field, but as the coach on the sidelines. It doesn't solve the problem itself. It just watches. It watches the main AI work through each step and gives it a little thumbs up or a thumbs down to make sure it stays on the right track. So it all breaks down into this really simple but incredibly powerful loop. Step 1, the main AI just brainstorms. It generates a whole bunch of different ideas for how to move forward. Step 2, the PRM, our coach, scores every single one of those ideas. And then step 3, the system just picks the path with the highest score. It's basically building the best possible answer one perfect step at a time. And this is where it gets crazy. This chart just brilliantly illustrates the mind-blowing result. You're looking at a super challenging math benchmark. And that tiny bar, that's a 1 billion parameter model using this test time scaling method. And it was able to outperform that huge bar next to it, a massive 405 billion parameter model. I mean, look at that. The little guy actually comes out on top. It's wild. And let's be super clear. We are not talking about a small difference here. The smaller model with its coach and a little more time to think outperformed a model that is over 135 times its size. That is just, it's like a go-kart lapping a freight train in a race. It shouldn't be possible. And this wasn't just a one-off, a lucky fluke. Nope. The results are absolutely stunning across the board. We're seeing models with just 500 million parameters beat GPT 4.0 on math. We're seeing 7 billion parameter models beat some of the most advanced reasoning systems out there. But here's the real kicker, the part that's truly game-changing. It does all of this while being up to 1,000 times more computationally efficient. That's insane. So, okay, this breakthrough in efficiency is cool, for sure. But it's not just about solving math problems faster. The real story here is what we can do with all that saved computational power. It opens the door to the next massive evolution in AI, building systems that can see and hear, not just, read a bunch of text. We're in the middle of this huge shift, moving away from what's called unimodal AI, that's AI that only understands language, to multimodal AI. And these are the systems that can see, hear, and process info from all different sources at the same time. We're talking text, images, audio, the works. It's a lot more like how we experience the world. It really is the difference between an AI that can read a book and an AI that can have a full-on conversation with you. So how does this work? Well, it's a pretty sophisticated pipeline. First, the AI has to take each type of data, text, an image, some audio, and convert it into a language the machine can understand. Then, and this is the clever part, it projects all of that into a shared space so that the word dog and a picture of a dog can actually be compared. Then it fuses it all together. This lets it find these incredible connections, like linking the words in a sentence to specific objects in a picture, giving it a way richer, more contextual understanding of the world. Okay, so here's where it all comes together. Here's why this really matters. Those incredible efficiency gains we saw from techniques like test time scaling, they free up a ton of computational power that we need to build these way more complex multimodal systems. Basically, making the thinking part cheaper means we can spend our computational budget on giving AI eyes and ears. So it's really not just about being smarter in a narrow, text-based way anymore. The goal is to build a broader, more holistic, and ultimately a more human-like form of intelligence, something that can deliver much, much richer experiences for all of us. Which, leaves us with one final thought. Maybe that whole heavyweight race for sheer size, maybe that was just the warm-up act. And maybe the true frontier isn't about making AI models bigger and bigger, but about making them more resourceful, more efficient, and way more versatile. Subscribe, the future of AI is getting smaller, and you don't want to miss what's coming next.